If you don't know me, I'm Jake with Clarity Coders. I've been working with Replit for probably a year now on different projects, and this is one I'm very excited about. We're going to create a game today using Replit and Kaboom.js. Now, this is super exciting because Kaboom.js allows you to get a game spun up very quick, and I'm going to go over most of the concepts you would need to create just about any game. So we're going to cover collisions, movement, input with the keyboard and the mouse, resource management, a lose screen, a win screen, adding dynamic levels, and much, much more. What we're going to end up with at the end of this tutorial is a game that is fun to play, but also has everything in it that you could use to build your own idea, whatever it might be at the end of this. So let's not waste any more time and get started. The first thing I'm going to do, if you haven't already, is head over to replit.com. Go ahead and sign up if you haven't already, and then we're going to click Create REPL. Once this pops up, we're going to search for Kaboom, if you spell it correctly. I'm going to select Kaboom Platformer. So this platformer is going to give us some objects already to manipulate and different things like that. So we're going to go ahead and select that. You can give it a title of whatever you want, and then Create REPL. Now, hopefully you've come to a screen that looks a little like this. Now, at any point during this tutorial, if you don't have any of these sprites that I have or something like that, just use another similar one to it, and that'll give you kind of the same look that I have. Now, we're going to go ahead and start a little fresher than what we have here. So what I want you to do is go ahead and delete all this, and we'll code and talk about it as we code through this project. So the only thing that I'm going to leave here is import Kaboom from Kaboom. Now, what we can do here is we can go ahead and start working with some assets. So the first thing we might want to do is import some assets into our project. Now, you can do this in a couple different ways. You can add using this plus symbol, and this will take you to a creation. You can upload, or you can use some of the built-in assets that you can see here. So what we're going to do is we're going to go ahead and add this into our project. So we're going to go back to main here. I'm going to go to insert code, and I'm going to load in this sprite. You can see right here that it's loading just a simple PNG. So you can do this yourself with other things if you'd like, and then we're giving it a name as well. Let's go ahead and insert an enemy as well. And while we're at it, we'll go ahead and insert a block that we can stand on. Perfect. Now that we have our assets, they're not going to show up on the screen yet. I'll move this down, and I'll actually, before I forget here, I'll change the font size to a little bit bigger as well, so hopefully you can see better. So now that we have our assets loaded in, we can go ahead and create our first map. So the map is going to be how we bring objects into the world and how we design levels. So we can name ours under a variable. We can just call it map, and we can set it equal to, and then you can use your square brackets, and we're going to input strings. Now, each of these strings is going to be a visual description of our level, and each symbol we use is going to represent one of our sprites from the side here. Now, that may not make a lot of sense right now, but let me show you an example. So let's say we want to use equal signs as the ground. We can make a ground, 2 spaces, and then some more ground, and then some more ground. Now, don't overthink the spaces. It's no big deal if yours is a little different than mine. And we can go ahead and add some more here, and you're going to have a comment between each of these lines. We'll make these ones blank. So you can see here I got 1, 2, 3, 4, 5 blank rows, and then some sort of ground down here as well. Now, it doesn't matter if yours is a little different than mine, but you want to make sure that you have a comma after each of these and a single quote inside of the line itself. So now that we got our map set up, which is pretty exciting here, as you can see, we can go ahead and start configuring our level a little bit. This is where we're going to define to Kaboom what these symbols mean. So right now we only have a blank space and the equal sign, but we need to define those. So let's set this up as a constant. So we're going to say constant. And I'm going to call it level CFG. So for level config. And I'm going to set that equal to, and we're going to use curly brackets. Now inside of this, I want to say what each of my symbols is going to be size-wise. So I'm going to say the width equals 64, and then the width equals 64 again. Now we can go ahead and start defining our symbols. So the only symbol we have right now is an equal sign. So I'm going to use the 2 quote marks, and I'm going to use an arrow function here. If you're not familiar with that in JavaScript, that's okay. But basically what it's going to do is we're going to define an in-place function. And in this case, it's going to have a very specific use. Kaboom is going to use it to define what the equal symbol means in our map. So the first thing we want to say is, what should it look like? Well, we want it to look like our grass symbol because we want this sprite to be the ground. So the equal sign we want to be ground. And remember, we loaded in this sprite on line 5 and we named it grass. You could have named it anything you want. We'd use the automatic pull-in code, but you could have named it ground or whatever you would want. You just have to make sure these 2 terms match up, whatever you name it as. Now we can give it a tag that we can use later for different things like collision and whatever else we want to do. We are also going to give it an area. So this is going to allow it to be a solid surface that we can stand on. And then we're going to finish that off by saying solid. And actually, these shouldn't be curly brackets. These are going to be square brackets. Perfect. Now we want to go ahead and put our level together. We want to show it. So let's create another constant, and we can set that as game_level. And we can set that equal to add level. And then we can pass in our map and our level configuration. So we remember we saved our map as map, and we saved our configuration as level config. Make sure your spelling and capitalization is consistent here. You can see that I called this level config with a capital C. We could also do something like level_config. It doesn't matter what you name it here, but you want to be consistent with these. This will cause an error if I don't have them named the same. So let's go ahead and make sure those are named the same. Let's go ahead and call it level_config. Level_config. Perfect. And of course, before we get this to work, as I messed up here, we need to call Kaboom as well. So Kaboom. There we go. And we're hitting our run up here. And we forgot to define our height. So we want one to be width and one to be height. Now we'll stop again. Now remember, as you're going through this, you have to really read the errors. That one said we hadn't defined a height for our level, so that can help you kind of trace back what's going on with your program. Now we could have edited that out, but we want to make sure that along the way, we're looking at our errors and kind of learning from them as well. So what I'm going to do is when I run these, I'm going to actually copy this URL down here, and I'm going to paste it into another browser that I have open. What that'll allow me to do is show you guys what it looks like in a full screen, and you should probably do the same because this window down here gets a little scrunched and different things like that. So I'm going to kind of minimize it. I'll pull it up to show you errors and different things like that along the way, but that's how we'll kind of set it up. So now you can see here that our game has blocks, which is cool, but not very exciting because we don't have a hero in it, and we also don't have any enemies. So let's take care of both of those. The first thing we might want to do is add a hero into our game. So to do that, let's add a constant that we're going to call our hero. So we can call it hero. We can set it equal to add parentheses and square brackets. Now we're going to do something similar to what we did in defining the level above. So we're going to define some things about our hero. First of all, he's a sprite right now, or she. And we name this sprite Bean. That's going to be our hero. So we'll call it Bean. We can give it a starting position. So we can say something like, we want it to start just off of the left side. So the first is your X coordinate and the second is your Y coordinate. So we're going to say we're going to start him 30 pixels from the left. And we can start him at the top of the screen. Now remember, we're putting commas after these as well. We're going to say he has an area, so we can use him in collisions and things along that line. And we're also going to use the body tag. So as you can see from this pop-up here, so Replit does a good job of having these pop-up windows that kind of explain functions, but the body is going to allow us to have this object respond to gravity. So he will drop down if there's no solid ground below him and that sort of thing, which we'll see here in a minute. We can also adjust the scale of our sprite. So right now we'll start at 80%, so we'll do 0.8. But you can play around this to make it feel right in your game, whatever that size may be. But I'm going to put it in here so you know how to adjust that size. And then finally, we can give it a tag as well. So if we wanted to say something like this is our player, we could add that in or something along those lines. So we'll show how we use these later, but a tag is something that we can use to group objects together if we want to perform an action to them as a whole. So if, for example, we wanted anything with a tag enemy to kill the player, we wouldn't have to do it for each unique enemy. We could do it for all enemies, that sort of thing. Now you notice the red line here, it shows us that something's not quite right. It actually wanted me to put a comma above here. So remember, each of these lines you have to put a comma above to make sure it's working. And you might have seen it, our player drop down there. But if we save this, we can copy this URL. And if we open it up I'm going to open it up in our other browser. You'll see that we have a hero here. Awesome. But again, not very exciting, right? Because the hero doesn't do anything. So we need to address that issue. We need to perform some movements with our hero. We can add those below here. So we're going to use some new functions here. We're going to say on key down, and you can see it's popping up there. Now, as we get into this, you're probably saying, okay, this is great if you tell me every single function that exists in Kaboom.js, but how would I have ever figured out that to add movements to my player, it's on key down or on key right or on key left? That's where the documentation comes in. So if we head over to Kaboom.js.com, you can take a look at the documentation and find all the different functions that I'm referencing. This is how I learned how to use the library itself. So hop over here after this video and you can learn even more about different things that you might want to try with the library. Now you can also do things outside of the library. It's just JavaScript, so you can add in whatever functionality that you want. But they've added in a lot of features to do almost anything you need to do to create your game. So with that being said, on key down means we're going to press a key. Now we have to tell it what key we want to press. So in this case, let's say we want to press the right arrow key. So we're going to say right, and we're going to wrap it in quotes, comma, and then we're going to do our friend, the arrow function again. You're going to get good at that. So how we set that up is the two parentheses, the open and close, equal sign, the greater than symbol, and then the curly brackets. Now, right here, you want to make sure the syntax is correct. You got your parentheses all lined up, the equal sign, the greater sign, the open curly bracket, the closed curly bracket, and then the closed parentheses. It's got to be identical to that. Now's the easy part. We named our hero above hero, so we can say, when we press down the right key, we want our hero to .move, and then we want it to move some amount. We can say 100 on the x-axis, and on the y-axis, when we push right, we want him to move 0. We don't want him to move up and down when we push the right key, just to the right. So if we save this, and we go back to our game, we can rerun it. Make sure you click into the window too. And now if you hold down your right key, you can see your hero can move. That's pretty cool. So one thing you might want to do is start pulling some of these hard-coded values out. So what we want to do is maybe set some constants above that can easily be changed. So we'll say constant hero speed equals 100. Actually, if we're following some syntax here, we might want to do capitals as well. Typically, we're going to use capitals when we're referring to constants. So I'm going to do hero underscore speed. We can move down and we can replace that with hero speed. And you'll see here why I'm going to do this in a minute. So now I can copy this code, paste it, and I can change right to left. And now I want him to go backwards. So if I hold the left key down, I want him to move backwards. So I'm going to give him a negative value on the x-axis. Now, here's where the variables come in handy. So if I wanted to change his speed down the road, if 100 was too slow or too fast, now I have it in 2 different spots. Maybe I have it in 10 spots by the end of this program, but we've moved it to a constant above that we can adjust right there. At the same time, if we wanted to give him a penalty, say he eats a poison mushroom that makes him slower, we could say times 0.5. And now whatever his base speed was is halved. So kind of some stuff down the road that we can do here. So now if we save this, refresh and make sure you're clicked in, now we can see that we can move our hero back and forth. We also might want to add the ability for our hero to jump. So what we can do is I can copy this code again because I'm a programmer. So we like the Control-C, Control-V. And we can add another key here. I'm going to say spacebar. Now this time we can move our hero a little different. We want to do hero.jump. This is a built-in function for upward thrust in Kaboom.js. And we can give that whatever value we want. So we can say 50. Now if I save this and I rerun it over in my browser, you can see we still have our movement, but we also can jump by pushing the space bar. Now, if you're really quick, you might notice that you can tap and jump multiple times. It's kind of hard to see. Let's change this to 150. And now if I click into this window again, you'll see that I can keep jumping, which is an issue. We don't want him to be, well, maybe you do, but right now we don't want him to be able to jump like that. So we can use a built-in function in Kaboom.js to see if our hero is on the ground, and we're only going to let him jump if he's on the ground already. So we can say something like if, and then we're going to check a condition here. So we're going to see if our hero dot grounded. So what that's going to do, it's going to return true if he's on the ground. Now we're going to use curly brackets, and we want to put the other curly bracket, the closing one, after this line. Now to make it look a little better, we're also going to tab this inside. So let's break down this little code block here. So what we're doing, we're saying if our hero is grounded, so if this part returns true, we're going to let our hero jump. If this returns false, this code will never run, so our hero won't jump. So we shouldn't be able to double jump anymore. Let's change this to 500. Why not? So now make sure we reload our game, and if we reload our game here, you can see that now I can jump, but I can no longer double jump. I can only jump when I'm touching the ground. So now, as you can guess, we can make a constant for this as well. Let's go ahead, our hero's a little slow too. Let's change his speed to 200, and then let's set a constant for our jump power. We can say jump power, and we'll set that equal to 800. So now if we go down here, our hero speed is already updated because we use that constant, and we can change our jump power to 800. Now we might want to add another key. Maybe someone pushes up instead of spacebar to jump. So we can copy that and we can set that as well. So now if we go back to our game, you can see that we can move and jump freely in our level. That's pretty cool. You'll notice if we jump through the hole, it just goes in the hole and nothing happens. So that's an issue, but we'll come back to that. So let's go ahead and add some other things to our level to make it a little more exciting. So I'm going to add 2 more rows. So I'm just going to copy these. Oops. I'm just going to copy these, paste them in, and then I'm going to add a ghost. So you can use whatever symbol you want, but I'm going to use this caret above the 6 key. So I'm going to hold shift and hit the 6 key. And I'm just going to add these in randomly. You can truly put these wherever you want. Now, our game has no idea what this caret is, right? So we have to define that in our program itself. So what we can do is we can go down to our level config and we can add another definition here. So what we're going to do is we're going to add another definition for our caret symbol, or whatever symbol you chose to use. And we're going to do that with our old friend, the arrow function. Make sure to use square brackets this time. I did not before. And I'm going to put a comma after this just so we're ready when we add another symbol that we don't mess it up. So now we're going to define this symbol. So we're going to define the attributes just like we did with the grass. So we're going to say sprite is equal to whatever we called it above, which was ghosty. We're going to give it any tags we want to give it. So we can give it a tag for ghosty. Remember, we can use this to grab all the items. Or if we wanted to be more generic for all of our enemies, we could do something like enemy. So we can later say if any enemy collides with our hero, it loses. But give it any tags you want. We also want to give it an area. So why do we want to do this? Well, later we might want to test for collisions and different things like that to see if our character loses. So we want to give it an area so we'll know if we've hit that ghost or not. Now let's try and save this and just see what it looks like. We can go back to our game. You're going to have to reload it. And cool. So we got ghosts on the screen. Not very exciting right now, as you can see. We can't hit them. So at this point, you're probably starting to wonder, okay, I'm guessing we can add some code to collide with these objects and tell if we've lost or won or add different conditions like that. But how do we advance to different screens? So Kaboom.js does that with scenes. So what I like to do is I like to set up pretty early a lose screen, a win screen, and a game scene itself. I said screen, but I meant scene. So we can do that by defining different scenes inside of our game. So the first one I want to do is the main scene of our game, which is the actual game scene itself. So what I'm going to do is I'm going to create a scene. And I'm going to name it whatever I want to name it. In this case, I'm going to call it game. And then I'm going to do our handy dandy friend, the arrow function. Now, all this code we've done so far, I want to put it inside of this game function itself. So what I'm going to do is I'm going to copy the curly bracket, the closing curly bracket and the closing parenthesis. And I'm going to pull it clear to the bottom. And then I'm going to highlight all the code in the middle. So now I got it all highlighted. And then I'm going to push the tab key. Give it just a second here, and you'll see that we've now put all of our code inside of this game scene. This is going to cause an issue, however. So right now, nothing will run if we save and reload our game. So now what we need to do is we need to tell Kaboom what scene to go to. So when the game first starts, we want to go to the game scene itself. So now if we save, we should end up with the exact same game that we had before, but we're set up now to handle collisions and different things like that. Now that we have the game scene added, we can make another scene, and this is going to be the scene that we go to when we lose. So just like we did above, we can add a new scene. We can call this whatever we want. In our case, we can call it lose. And we can add our handy dandy arrow function. Now this screen we're going to keep pretty simple for right now, and we can add to it as we improve this game. But let's just add a text block that says lose on it. So we'll do add square brackets. We can use the text command, and we can add a string. You can say whatever you want, but I'm going to say you lose. And then we can define some other things about this text block. So we can set the color, for example, and we can set this with red, green, blue values, I'm guessing. So we'll try 255, 0, 0. And of course, like I said, I was making a guess here just based on computer science and how it usually works. But you can see this nice little pop-up that pulls up, and it has the RGB value 0 to 255, and it even gives you an example of adding something and coloring it. So let's add another comma here. We'll say that we want to center this text, so we can say the origin is center. And finally, let's position it in the middle of the screen. So we're going to do position, and then we need to give an X and a Y coordinate, but we don't know how big the screen is. So we'll say however wide the screen is, so we'll do width. Let's divide that in half. And then however tall the screen is, so we'll do height. Let's divide that in half. So our X coordinate is going to be half of the width. Our Y coordinate is going to be half of the height. And that will be our lose screen. If you wanted to, you could test this. Instead of going to the game to start out, we could go to lose. If you save this and then reload our game window, you can see that it did in fact work. Now, of course, this doesn't make a lot of sense. We want to start with the game and then go to the lose screen if we would happen to lose. So let's go ahead and let's add a collision rule into our game. So let's say if our bean, oh wait, we called it hero. The sprite was bean, but we have a variable of hero. So if our hero dot collides, and this is a function built into Kaboom, so we can say with what it collides. So again, we could use a tag from above. If you remember, our ghosts have a tag of ghosty. They also have a tag of enemy. We could use either of those. So let's say we want to do any enemy. So if we collide with enemy, anything tagged with enemy, we want to do something. So we can use our handy dandy arrow function. With one difference. This time we're going to pass parameters into here so we can do stuff with our different items on the screen. So in this case, we can pass in the enemy, and this will give us access to whatever enemy we ran into. So we won't use it right at first, but maybe we want to do something with that enemy. So for right now, let's just say we want to go to our lose screen. So if for any reason we hit something tagged with enemy, we're going to go to our lose screen. So we're going to save this and reload your game now. Now make sure if you pointed this to go to the game or go to lose at the start of this, that you're pointing it back at go to game. Awesome. Now that you have your game, if you click into it, you should be able to move around. And if you hit an enemy, you can see you lose. That's awesome. So we added some functionality here based on what's happening in the game itself. Now, something real annoying right away when you're trying to develop. Now I'm stuck on this screen and I got to reload if I want to play again or something like that. So right away, let's say on the lose screen, if we push any key, we're going to restart the game. So to do that, we'll add some functionality to our lose screen. We're going to say on key press, and then we can pass in an arrow function. Because in this case, we don't want to add a specific key. I said above, you could. I said above that I just want any key you press to automatically restart the game. You could say press R to restart and make it just the R key or whatever you wanted to do. But for right now, let's just restart. So we'll say go game. So now every time we press a key when we're on that lose screen, it should restart the game. Awesome. So I said I wanted to add a little bit of functionality here. So say you wanted to do something like Mario style, where if you jump on an enemy's head, it destroys it. But if you run into the side of it, you lose. We could add in our own custom functionality to this as well. And it doesn't really matter if it exists in Kaboom.js or not. So to demonstrate that, let's add an if condition here. So we only want to lose if our player runs into the enemy and he's lower than the enemy itself. If the player, the hero in our case, is higher than the enemy, then he's jumping on his head and we want him to just destroy the enemy then. So this should be a fairly common use case in your program, whether you, it could be a bullet destroying them or whatever the case may be, but you may need to destroy an enemy for some reason, and you may need some custom logic there. So what we're gonna do is we're going to say if something, some condition here. So let's say if our enemy dot position dot y-axis is less than our hero dot position dot y-axis, then we're going to go to lose. So I enclose this lose with curly brackets. And now this might be a little confusing because the y-axis becomes greater the farther down the screen it is. So if our enemy's y position is less than the hero's y position, that means the enemy is actually above the hero when we collided. If the enemy is above the hero when we collide, then we lose. If we're higher than the enemy, then we want to destroy that enemy. So we can say else. And remember, an else condition, we're not going to have any sort of condition. It's just going to be the catch-all. So we can just say something like enemy dot destroy. And that will remove the enemy from our screen altogether. So let's save and try this because we've done a couple things here. So let's go ahead and save and you can reload your game. So now hopefully you have a enemy low enough that you can jump on him. But you can see here, if I jump on the enemy, I destroy it. If I hit it from the bottom, I lose. So that's kind of some cool functionality there. Now if I push any key, I should be able to restart here. Now, one thing you'll notice is when I'm doing this, there's no really reaction to the enemy. Like you think of a game, I think of if I jump on something's head like in Mario or something, I might pop up a little bit or something like that. So we can add any functionality you want. It's your game. So in this case, I can say something like hero jump 1000, say. So I'm going to destroy the enemy and then I'm going to get a little pop after I jump on him. Now let's save this again. We can reload our game. And now if I jump on something, you'll notice I get a cool little pop. All right, very awesome. So you can see here how we can kind of build our own functionality. One other thing you might have noticed is right now, if we fall through a hole, he just falls forever. And we can also see from that, although it's not really apparent right now, that the camera isn't following our hero either. So if the level's too big for the screen or something like that, or in this case, he drops off of the earth, we don't follow him through that process. Maybe you want that and maybe you don't, but those are two things that we want to take care of here. So these can both be taken care of in a special kind of block. So we're going to have a block of code that runs on an object every frame of the game. So in our case, I want to do this on the hero, and I want to set a dot action. This, maybe you can guess, we pass in an arrow function. And we can do whatever we want every frame with the hero itself. So in my case, I want to set the cam position, and we can pass in an XY coordinate. We can do whatever we want here. But I just want it to follow our hero around the screen. So what I can do is say hero.position. So this is going to automatically, every frame, adjust the camera to follow our hero around. Now, we can also go to a lose screen. So you can do this in a lot of different ways based on if our hero has fallen off the map. Now, this is going to be different depending on what the X and Y coordinates are, but I'm going to kind of do a little catch-all here. So I'm going to say if our hero dot position dot y is greater than, pick a big number, say 2000. So I'm going to say if our hero gets below 2000, go to the lose screen. So we'll go to lose. So hopefully two things. We're going to save this and run our game again. Hopefully two things. Hopefully now our camera will follow our hero around. And also if we fall off the map, we will lose. Don't forget to click into the screen so we can run our game. And now you'll see we do, in fact, the camera does in fact follow our hero around the screen. including falling. And you'll notice it waited a little bit and then hit the lose screen. So that's because I set up that 2000. Now, if you set this up too low, he might die right away. So if I say it's greater than 10, and you'll notice he doesn't even get into the game before I lose. So you gotta be careful with different things like that, but we'll set it to 2000 for right now. So one thing that makes me a little icky feeling in my stomach is the background. So the background right now is that checkered squares. Let's change that to something solid. So if we wanted to change our background to something solid, we could add it into our Kaboom call up here, along with other things. But we'll start with the background for right now. So we can add curly brackets here. And then we want to add a background. And we'll pass in square brackets. And we can give an RGB value here. So in our case, we might want to do like a dark gray maybe. So we could do like 35, 35, 35. We'll just see what that looks like. All right, cool. It doesn't look great, but it looks solid, and it's at least not giving me the icky feeling in my stomach. I don't know, that kind of makes me sick, those transparent squares. So we got something going here, but as you'll notice in your game, your enemies don't have a lot of functionality right now. So you probably want to add some functionality to them. You might already be thinking where you could do this, right? So we have a hero action every frame. So maybe we could do something similar to give our enemies something to do every frame. Like maybe move somewhere or something like that. Right now the stationary isn't very great. We also have no way to win our game right now either, which is a little obnoxious. There's no actual game yet. So we're gonna handle both of those cases coming up here. Now, first things first, let's add some actions for our enemy here. Now, we can add a base action like this, and then we can use a tag this time. So what this is going to allow us to do, it's going to allow us to affect all whatever that has this tag. So it might be enemies, it could be resources in the game, whatever you want it to be. In our case, we could use enemy because we gave the ghost a tag of enemy as we used up here. Or if we start to have more than one enemy, they might all move differently or something like that. So we also gave the ghost a tag of ghosty, which is very specific to this specific type of enemy. So let's use that here. Now, we don't have more than one enemy right now, so it doesn't matter which you choose. This is, again, just kind of a use case here. So we're going to use an arrow function. Surprise, surprise, right? And we can pass in this object. So whatever particular object we're talking about in this case, we can pass that in. So we can call it whatever we want. We can call it G for ghost or whatever. And then we'll have the ability to use it in the action itself. And this function is going to run one time for everything that's tagged. So each of these G's is going to come in. So if we have 8 ghosts, this is going to run for each ghost individually. So let's just say we want it to move. So we can say g.move. And then here we can say something like whatever speed we want it to move. So we could say 10. And then we don't want it to move on the y-axis at all. If we just save this and run it, wow, look at that. Those are moving now, huh? Okay. So you could probably, well, a couple things here. One, we need them to move faster. They're not moving very fast right now. And 2, it probably might be a good idea to set a base speed for our ghosts as well. So we could do this in a couple different ways. We could give a constant above, which we'll go ahead and do. We could say a constant, let's call it ghost speed. And we could say it equals whatever we wanted to. Our hero moves at 200, so we could say 150 maybe. And then we could use that all the time. So we could come down here and we could say we always want to move with that constant ghost speed. But something that we might want to play around with is maybe we want the ghosts to move at different speeds for different reasons, right? Maybe they have this base ghost speed, but every ghost has its own unique speed. So we can give objects custom attributes. So where we define ghosty up here, so we said it was the little caret, We define the sprite as ghosty. We gave it some tags. We gave it the area. We can also give it custom attributes. So let's give it a custom attribute here. I'm going to put a comma after this just in case we add something else down the road. And we can say speed. And we want it to start out with the base of our ghost speed. So again, maybe if we jump on its head the first time, it doesn't kill it and it just slows it down. Or maybe it makes it mad and it speeds it up. So then each ghost can act uniquely with their speed down the road. But they're all going to start with this ghost speed. Okay, so to make sure this would still work, but to make sure that we use whatever this ghost's current speed is, so maybe that base speed has changed, we can do g.speed with that custom attribute we set above. So now it's going to move at whatever that custom ghost speed was above. Now if we go and reload our game, you can see they're moving really fast. Let's go ahead and slow that down a little bit. And you'll also notice they just leave the screen as well. So a couple things there. One, our enemies are out of game really quick. And two, they're way too fast. So let's go to our constant. Again, this is the nice way, or the nice reason of using constants at the top. We can adjust that to 100. It'll slow down all of our ghosts. And then another thing that we realized here is our ghosts eventually just leave the environment altogether. So something we might want to do is reverse the ghost direction once they hit a certain point. So remember our x coordinates control the horizontal plane. Once they get past a certain point, I might want to turn them around and come back on the screen, right? So they stay kind of on a level in one spot or another. So let's say if our g.position.x, it would help if I had an if statement. So if, and then parenthesis, x is greater than 1,000, and we can do this in cleaner ways. It's just an example right now. So if it gets greater than 1,000, then we want the ghost to start moving the other direction. So how can we do that? Well, if his speed is currently 100 and he's moving to the right, to make him start going the other direction, all we have to really do is flip his speed value to negative. And if he's already has a speed value of negative, we just need to flip it to positive. So we can set g.speed equal to whatever his current speed is times -1. So we're just going to flip it. If it's 100, we'll take 100 times -1 and it'll start moving -100. If it's -100 already, we'll take -100 times -1 and he'll start going 100 to the right again. So this should keep our guys on the screen. But we have another condition, right? What if he hits that wall and then he starts moving to the left? He's going to go off the screen to the left. So we need to add an or, and we can say our g.position.x is less than, say, -1,000. So this should keep our enemies sort of confined on this level. We're going to do something to keep them kind of dynamically on the screen later, or all moving uniquely. But for right now, this is a good look. So let's reload our game. I save that, reload the game. And now you'll see that already some of our enemies are coming back and forth. You also notice he goes too far off to the left and doesn't go really far enough to the right. So maybe we can change this to 100 and maybe this to 1,500. Let's try again. All right, now you'll notice that looks pretty good, I think. So we don't have a game yet because we can't win, but we do have some ghosts, some enemies moving on the screen. We have a way to interact with those enemies, both to lose and to destroy the enemy. Let's go ahead and use a couple more resources to make a way to win the game. So right now we have a scene that says lose. Let's copy this whole scene and paste it. And let's edit this to be a win screen. So let's say this scene is called win. And we can say you win. And instead of being colored red, remember it's red, green. Let's say it's full green. And we're going to center it and all that. And you can press to start the scene over as well. So we have everything we need for a win screen. Not a very exciting one, but we have it there. Now let's scroll up to the top and let's add a resource that will down the road get us to the next level, or in our case, if it's the last level, it will get you to the win screen. So let's add in this portal. Now again, if there isn't a portal here, you can design your own, you can load your own PNG, whatever you want to do. We're just using the default one that Replit has there for us. And the name that they have for it is portal. So let's adapt our map here. So we want to create a portal, and this is what's going to take us to the next level. Now you can use any symbol you want, not the ones you've already used, but we can use a new one here. So our asterisk is going to be our portal. And now we can add some details about that portal. Well, that portal, all we really want to do is figure out if we've touched it or not. And then we know we can either move on to the next level, or if it's the last level, we can move on to the win screen because we beat the game. So we're going to say asterisk or whatever symbol you used above. We're going to set up our arrow function. And then use square brackets again. I'm going to put a comma just so we don't forget if we add another resource later. We can say what sprite we want it to use when it sees that asterisk. In this case, we want it to use portal. Comma, and then we want to give it any tags we want. So we can say portal for a tag. And then we can give it some area as well. So we can test for collisions. Awesome. So if we reloaded this, that should show up on the screen. We're confident, fairly confident that that would happen. So we'll leave that as is for right now. How do we win the game? So, or move on to the next level, or how do we advance? So in our case, let's say if we get to the portal, we're going to advance to the next level. If there's no more levels, then we're going to win the game. So if we scroll down, you can probably guess how we could accomplish this already, but we can add another collision here, and I'll add it in this spot just so it's kind of consistent with the other collision that we're testing for. We'll say hero.collides. If it collides with our portal tag, we can pass in an arrow function. So I'm going to do an arrow function, and you'll notice here that I also passed in a P, which is going to be the object, whatever that is, that has the tag of portal that we collide with. Why would I do that? Well, maybe we want to do something like destroy the portal. So we could do p.destroy, and that would destroy the portal. In our case, we probably don't need to do that because we're moving to a different scene if we hit it, but just an example. In our case, right now, we want to go to the win screen. So if we hit the portal, we want to go to the win screen. So let's go ahead and save this and make sure to reload your game. And bam, we won. Awesome. That's not very challenging at the moment, but we can adjust that as well, right? So let's say we want to move the portal to be up here. And we can add another enemy just for fun. We can even make all these a little bit higher. And if I save this, you can see how easy it is to customize our level. Okay, that's great, right? But we might need to manage some resources in our game. So right now we don't have any resources in our game. Resources could be anything. Things that you use in the game. Could be coins, could be score, could be time. Anything you want to display or use in some way. I guess not time really, but that could be game information. So let's add some of that to our base game here. So maybe we want to start keeping track of two things. We could do let level ID equals 0. Since we're in computer science, we're going to start, our first level is going to be level 0. And then the second one, we might want to keep track of the kills too. So maybe we want to keep track of every time we jump on an enemy or something like that. So let's set those two up. And now these are going to change, right? So I didn't use constants because I want to keep managing these as I go through the game. And now in our game, I'm going to do this right after our configuration here. We can display some information to the screen. So let's add what level we're on, and let's add how many kills we have so far. So I'm going to say constant level underscore label equals add. We can add some text to the screen. We're going to say this is our level, and then I'll add a space here, and I'll say plus, and then we'll add in whatever our current level is, which we only have one level right now, so it doesn't make a lot of sense, but we're going to create more. We can define where we want this to show up. So we can start it at the very top corner. You can give a scale here as well, so you can either scale this up or down depending on how big you want it. Right away, we'll just throw something out here. So the scale starts at 1. We'll throw something out here just because I know that's probably going to be too big. So we'll say we start at like 0.7. We can say we want it to be fixed. Now what this is going to do, it's not going to move with the player or anything like that. It's going to stay fixed at position 0, 0. And let's go ahead and give that a try. So let's save, reload our game. Cool, so we have the level we're on up above. Now that's not going to change, we know, because we only have one level right now. We're going to fix that in a little bit, but let's add something a bit more dynamic. So let's also keep track of our, we can call it kills at the moment. So maybe this is our score down the road, maybe it's something else, but right now we can call it, we'll just call it our score. So we're going to give 1 every time we jump on an enemy's head. Now you can probably do this yourself. It's very similar to what we did before. So we're going to say we're going to add another constant score label. Same thing as before. We could even copy this if we wanted to. Well, yeah, let's do it. Why not, right? So we'll copy that. We'll paste it in here. We can say this is our score. Now remember, we got to use whatever variable we used above for our kills, which was just kills. The position we obviously can't leave the same, right? Because if we did, it would overlap the other score, the level score. So let's change the Y to add 70 pixels. So that should bring it down the screen a little bit from our level. So we're going to assume that probably will work here. So how do we increase this amount of kills? Well, if you remember, we check to see if we collide with an enemy. And when we do, if we're higher than the enemy, we destroy that enemy. So what we can do is we could increase that kills by 1. So we could do kills equals kills plus 1, or the shorthand, we could do kills plus plus. Update actual text on our scoreboard above. So we can say score underscore label dot text. We can set that equal to our new label here, which is going to be score space plus whatever our new kills amount is. Now you'll notice it's working. That's awesome. Okay, so let's add a little different functionality to this. So say, for example, we want some sort of resource that we can use in the game. So one thing that I thought would be cool is, what if the portal was too high for us to reach? So let's add a couple more rows and make it a little too high to reach. I'm going to copy these, paste them in, and then we'll make the portal way up here. So you see, I don't think even if we jump on the enemies, we can get up to that portal. So what if instead of kills, so what if we kept track of kills, but also every time we jumped on a ghost, we got a resource called a ghost block. Then we could click the screen and place that ghost block and use it to get to the portal. So it could almost be kind of a building sort of game. So how we can do that is let's add another variable to keep track of our ghost blocks. Because after we use them, we want to subtract one from that value. So we might still want to keep track of our kills separate, so we know how many enemies we killed in the entire game, but we want to be able to use these resources, these ghost blocks. Now let's make our own ghost block, because Replit has some stuff over here, but we want to show how we could create something as well. So I'm going to hit this little plus symbol. You can name this whatever you want. I'm going to name it ghost block. We'll do 32 by 32. I can hit create. And now you're going to really see how much I shine at art. So we have some basic options over here of things we can do with our pixel art here. I am, all joking aside, not very talented. So let's start with blue here. So I used the bucket and then I filled that bucket. Now we can add another rectangle and put that in there. I'm trying to mimic like the ghost blue sort of look there. And then I'm going to do a circle for his eyes. Oh, that is talented. I'm going to undo that. Let's draw his eyes. Something like that. Oh, that's pretty good. It's pretty good. Replit's probably going to hire me to be their artist. Okay. So let's make another eyeball here. Use that circle. Neat. Do a line for a mouth too. Okay, perfect. So this is obviously not my forte, but if you wanted to, you can draw as good of pixel art as you want here. And we're going to save this resource. And then we can close out of it. And you'll see that we have our nice ghost. Good Lord, that eye looks terrible. You can see that we have our resource over here. So in order to use this in our game, we're going to click back into main. We need to load this into our code. And you'll notice it pastes it all in for us. You can see how you could have written that out yourself, but we didn't have to, so that's nice. So what I want to do first, now we only want them to use a ghost block when they've collected that resource. But let's not worry about that yet, right? We're just going to try and see if we can get a ghost block onto the screen and then see if we can use that ghost block to get to the portal. And then we'll look into limiting how many ghost blocks they can use. So you might be on to me. One of the reasons that I'm doing this is so I can show you another way to handle input into your game. So down here at the bottom, we're going to look into handling a on-screen click. So if they click somewhere with their mouse, we want a ghost block to show up that we can stand on and try to get to the portal. So to deal with that, we're going to use onClick. And we're going to pass in an arrow function, as you could probably guess. And inside of that arrow function, we're going to get some information. We need to know the click position. Now, this is just a variable name. Remember, it doesn't matter. I could have called this pizza, but this is going to pass us the click position. We can call it whatever we want. I'm going to call it click_POS. Now, the first thing I'm going to do, just so I don't forget, is I'm going to convert this location into our game's location. Now, you can remember that our game is following around our hero, right? So the camera's moving with the hero. The pixels on your screen stay in the exact same location, so irregardless of where your heroes move. So we need to convert this into the world position. So we need to take our click position and convert it to the actual world position itself. So what I'm going to say is let our world_position equal, and like so many things, Kaboom has handled this for us. So we're going to say toWorld, and then we're just going to pass in our click position. So this is going to translate it to our world's position. Now, if we didn't do this, when we clicked on the screen, the block wouldn't show up where we actually clicked because our hero's moving around. So now if we click somewhere, all we want to do right now is just add that ghost block. So we're going to say add, just like we would any other time. We're going to add a sprite, and we called it ghost_block, I believe, comma. And then we're going to define some things just like we always do. So we could give it a tag. We could say ghost_block. Maybe we have something that happens on all blocks. We could just give it a tag of block. Maybe that could be, you know, something that happens to any solid block or object that we could stand on. We're not going to use that probably, but just for right now. We can give it a position. Now this is important. We want to use the world underscore position. So the one that we converted. If we don't, it's not going to show up where we think it's going to show up. We want it to have an area. And we want it to be solid. Awesome. So if we save this and go to our game and reload, you'll notice now we can add in ghost blocks. Oh, I put it up too high. And I win. Now it's pretty easy right now because we're not managing these at all. We're allowing the user to put as many ghost blocks as they want onto the screen. So let's change that. Now say hypothetically we still want to keep track of our score, which right now is how many kills we have. So we have a separate variable to track how many ghost blocks we have. Those values might be different because we want this resource to go down over time. So, just so we can keep track of that, let's take our score label and we can say this is our ghost label. Blocks, and we'll change this to be however many ghost blocks we have. Perfect. Now we also want to move this down a little bit, so we'll say 140. And now we need to start keeping track of this amount as well. So right now, every time we jump on an enemy's head, we add to our kills. We also want to add to our ghost blocks. And we also want to update our ghost label. I think we call it block label. And we can change this to blocks. And ghost_blocks. Now we're hoping this works, but we also need to update the ghost block value when we use one, right? So on click, we only want this to run and add a ghost block if our ghost blocks is greater than 0. So if we don't have enough ghost blocks, we don't want the player to be able to add any ghost blocks. So we're going to wrap this in curly brackets, tab this inside of our function, and now they should only be able to add one if they have a ghost block available. And when they do add it, we want to take our ghost blocks variable and we want to subtract 1 from it. And we also want to update our label. So we want to say our blocks underscore label dot text equals blocks plus ghost blocks. Then our player will also know how many they have left as well. So we coded a lot here without testing this, so we'll probably do a little debugging, but let's go ahead and rerun our program. You notice we're keeping track of this as well. That's a good one. So you'll see here it says block label is not defined. So let's pull up our console. This is a good opportunity here. We can see in main.js at 120, this error occurred. So if we go up to 120, you'll see that we update our block label, but we actually called it blocks with an S label. This is where naming conventions with your labels and different things like this are so important. To staying consistent, you'll notice here I actually called it ghost label, and really I wanted it to be any blocks. So let's change this to blocks label. So we have our level label, our score label, and our blocks label. Now on 120, let's make sure again. So on 120 we are updating our blocks label, so that makes sense. And then if we go down to where we would use one, we are also updating our blocks label here as well. So our naming should be fixed. So we can reload our game after we save, of course. And you'll notice our score and our blocks go up together. However, if we click, our blocks goes down. And if we click again, it doesn't let us add another block. Until we collect more. So our UI is a little clunky. Well, first of all, you'll notice that if we restart the game, our score and our blocks stay. We don't want that, but we'll worry about that in a second. And you also might notice this is kind of a little clunky now, having the score, the level, and all that on the screen. So maybe you don't want the score anymore. Maybe you're not going to use that, and we just want to keep track of how many blocks we have. You're welcome to remove that from the screen. So I'll walk you through how you could do that. If you go down to score, we can take out the score label. And I'm going to actually copy this so we can find anywhere it's referenced. I'm going to update our block level to show up at 70. Change this to be lowercase just to be consistent. And then I can Control F, paste in our score label, and then I'm going to take that out as well. If it was anywhere else, it would show up so we could fully eliminate it. Now, if I save this and run it, you'll notice that now we are back on our main screen. So we have a couple of issues here. If we restart our game, we're keeping our resources the same, and we don't really want that. And we also only have one level here, which isn't very fun. So we're going to take care of both of those issues. The first of those issues is I want to keep track of some information during my gameplay. So every time I play the game, I'm going to adapt this scene to have some information passed in. So every time we start a game, I'm going to pass in the current level, because we're going to have more than one level soon. How many kills we have, because maybe we're going to still show that at the end of the game. We're not really displaying it during the game. And how many ghost blocks we currently have. So now we're going to get an error because we're not passing in that information. So if we go down to game, now we need to pass that information into our game when we start our game. So we need to give a level ID, the kills, and the ghost blocks. Now if we save this and run our game, you'll notice it works again. But our replay game probably won't work, right? So if I lose and press any key to restart the game, you'll notice that we're not passing in the information. So what I want to do is when we go to a new game on a lose, I want to reset these variables. So I want to set our level ID equal to 0, our kills equal to 0, and our ghost blocks equal to 0. We'll format this a little nicer. There we go. And now we're resetting all of our information to 0 when we lose. We probably want to do something similar when we win, right? So on the win screen, we want to do the same thing. So I just copied and pasted. And let's test this out. And I forgot the S here, so we'll say ghost blocks. And you'll notice now we are resetting every time we restart the game. Now it's also a little clunky when we jump. Maybe we want to use a block in mid-air, right? And just put it right underneath our hero. That's kind of cool. It's kind of clunky to have to click. You might want to be able to click still. So we're still going to let that happen. But we might want to add some functionality for another key. So let's copy all this code. Now this isn't great. You should probably create a function for this. But let's say on key press. And in this case, let's say the key B. So if we press the key B, we don't care about click position anymore. We don't need to convert it anymore. But if we have enough ghost blocks, we still want to manage our ghost blocks and we want to place our ghost block. But instead of the world position, let's just place it underneath our characters. So you can just press B and it'll immediately spawn a ghost block right beneath you. So let's say we want it to show up wherever our hero is. .position.x, so his x coordinate. And then we also want to use hero.position.y coordinate, but we want it to show up a little lower than him, so we'll say 5 pixels below him. So now let's try and run our game again. Ah, cool. Now maybe that makes it too easy, but you can see how we can add more functionality here. Bam, we win. All right, perfect. So we've handled a lot of the different cases here. You might want to start adding new levels. And one thing that I think is pretty cool is being able to dynamically add levels and it to kind of know when it should go to the win screen or when it should find the next level. So to do that, we probably should create another level. So one thing we could do is we can make this an array of levels instead. So I'm going to add another square bracket here and another square bracket there. And we'll add a comma after the square bracket. And we can tab all this inside here. Okay, so now we can add a new level right below this. So if we copy this, level as a starting point. Now this is gonna break our code, so we're gonna have to fix some things. So don't try to run it in between here. And then paste it below. You'll notice now we have the exact same 2 levels right in a row. So what we can do is we can adjust this second level so we know it's different. So we might make the portal somewhere over here. And we can add in some more enemies. Again, not really worried about the specifics right now, just so we know it's a different level. Okay, something like that. So now we know it's a different level when we hit it, at least. And now we're going to use this level ID to grab whatever our current level is. So as soon as we start this level, let's go ahead and grab our current map. So we know our current map because we have the level ID. So this is going to be our 0 index level. And then when we move to the next level, we'll have our 1 index level. And we know that from this level ID. Now this is also maps now. It's not a single map. So our current map, we're going to look at our maps variable and we're going to grab out whatever our current level ID is. Now when we make this level, it's clear at the bottom right now, our game level, you notice we passed in the map. That variable doesn't even exist anymore. So now we're going to use our current map. So now if we save this, our game should work again, I think. Awesome, so it does work again, but we have no way to get to that second map. When we get to the portal, it's still going to kick us to the win screen. So now we want to do something different when we hit the portal. When we collide with the portal, we only want to go to the win screen if we're out of levels. So we want to say if our level underscore ID is less than maps.length, we got more levels to play, right? Well, and we also want to increase our level ID. So we want to increase our level ID every time we touch the portal. So in this case, say we touch the portal the first time, our level ID is going to go from 0 to 1. Well, our map's length is still 2 because there's 2 maps total. So we still have another level to play here. So in that case, we want to go back to our game scene. So we want to restart that game scene, but we have different information this time. Our level ID is our new level ID. Our kills is our current kills. And our ghost blocks are our current ghost blocks. Now you might see the notation like this. I wrote it out once and I shorthanded it once. If these line up 1 to 1 like they do, level ID equals level ID, you don't have to type them out like this. So we could actually shorten this and do level underscore ID, kills, ghost underscore blocks. We can do else. Else we're going to go to our win screen. So this should allow us to go to the next level. So if we still have levels left, then it's going to push us to that game mode. In this case, though, we do want to keep our resources. So if we have any ghost blocks, maybe you want to reset them every level. But in my case, I'm going to allow you to save up your ghost blocks so you can take that to the next level with you. So I'm going to save this, rerun our game. And you'll notice we made it to our second level. Awesome, so it works just like we would think. So we've successfully created a game with some very unique movement abilities for the player. We handled clicks. We can now dynamically add levels very easily. So we don't have to change any code. We could just go in and add another level, and then we'd have to play it to get to our win screen. But our win screen doesn't tell us a lot right now. So maybe we want to finish in a certain amount of time and keep track of who's done it the fastest, or maybe scores or kills or whatever. So let's look to add some dynamic content to our win screen next. Okay, so a few things we're going to add to kind of tidy up our game or get it at least in a good spot. We want to add a timer to see how fast we're finishing the game, like a speed run. So I'm going to scroll to the top of our game scene. And now here, if it's our first level, we can start the timer. So let's say if our level ID equals 0, because that's our first level. Let's do start_time equals time. So that should give us our starting time. And now when we go to our windscreen, we want to pass that information to our windscreen so we can display it. So we have our start time now. Let's go to so I'm going to Control F so I can find our win. So whenever we go to this windscreen, I also want to pass it some information, and that information is start time. So now if I go to the next instance of win, it's the actual scene. And here I can unpack my start time. So here I say you win, but then let's add in another string, and we can start that with /n, and that will put it on a new line. We can say your time, space, and plus, and then display your start time. But we need to get how long the program's been running since we got that start time. So let's say our current time minus that start time. Okay, let's try this, and you can go to your game and refresh it. And I might fast forward a little so you don't have to watch me play it, but and we got a little squirrely with our equation. That's why we get that nan value here. So let's wrap this in parentheses. So we want to take our time minus our start time, and then add that to our string. Before we are getting really messy with how we are trying to add values to a string. So now if we run it again, we should get our correct answer, which we do. And you might not like all the decimal places, so we could say .2 fixed. And we could say we want 4 decimal points or 2 or whatever you want. Let's do 2. Now if you save it and run it again, you should, when you finish the game, only have 2 decimals on your win screen. Awesome. Now let's do a little code cleanup to finish up here. So if I scroll up to the top, you can see that our window popped up again. You can see at the top here that our file's getting a little messy. Now this is why Kaboom gives you some examples of other files here. Now remember, we deleted all the code, so none of these are hooked up, which is okay, but I'm going to show you how you can do that. So the first thing you can do is you could create an assets file. Now if you don't have an assets file here already, you can add this plus and then add it in yourself. But we already have one here, so we're going to use that. So I'm going to copy all these loads here, sprites here, and I'm going to replace the one that Kaboom had built in here. So I'm going to delete everything inside of this and tab these values over so it looks nice and pretty. And then we have to call this function now. We have to call load assets. So back in our main, we can do import load assets from /assets. So that's going to load in this function. And then we have to remember to call it. So we have to call load assets with parentheses, and that will bring in all of those assets from that other file. So nothing has changed functionally. We're just loading in those resources. So we're not using this big file, so I'm going to delete that big file, delete the patrol file. Another one that I like to do, so if you keep adding in these maps, you could see how this is going to get kind of crazy in our main file, depending on how many levels you have and things like that. So what I'm going to do is I'm going to copy these maps, and then I'm going to create a new code file. So I'm hitting the plus, and I'm going to say maps. Now inside here, I'm going to do one thing. I'm going to define a constant of maps. Actually, I'll leave that. I'll just call it a constant for right now, and I'll paste this in. And you can see that we got our exact same maps before. We could capitalize this, but we didn't in our other file, so I'm going to leave it as is for right now. Now we need to export that constant. So I'm going to do export default and then maps. Now, as you might guess, we have to import that now. So we're going to import maps from maps. Now if we save this and reload our game, it should play exactly the same. Which it does. And you'll notice it did shorten our decimals as well. So all we've done here is I've shown you how you can move things out of this file so you don't have one ginormous file taking up a lot of space in your project. All right, so one quick other thing to our game to kind of finish it up here is let's do a sound. We haven't done that yet. So on our assets, I'm going to scroll down and there's a hit sound here. I'm going to insert that code. So we're going to load sound hit. Now it's important to see what it's named as here. Again, we could change this, but we have to remember whatever it's set as. So it's called hit. So let's go to main. I'm going to only do this when I kill the enemy. I'm going to play sound and I'm going to play hit. I'm not sure if my sound's on here on my screen, but we'll try and replay this game. And you can see that we are getting a hit sound. Awesome. So what we've done here is we've created a game with dynamic levels. It's a platformer. It has speedrun capabilities, so we can keep track of how fast you're finishing the game. And it has most of the resources you would need to create your own game, whatever those functions might be. If you like this video, please let us know, and we'll continue to make more and expand on this game and other concepts. Hopefully this gives you a base to get started in your Kaboom.js journey. Thanks for watching, and until next time, keep coding.